Welcome to Math 1314, Section 1.6 on absolute value. So, how do we know we have absolute value? Well, you've got these two vertical lines. So, I've got the absolute value of 3, and that turns out that that's 3. Absolute value of 0 is 0. Absolute value of minus 4, look what comes out. The positive version of it. This looks odd. Let's say I got a negative absolute value minus 5. All right, well, this minus right there in the front, I'm going to split that off as a minus 1. So it's minus 1 times this thing. Well, what is that? Well, the absolute value of minus 5 is 5. The minus 1 in the front multiplied by it, and I get minus 5. So notice, absolute value of anything I put in there is either 0 or positive. The thing that comes out is never negative. It just doesn't do it. So the formal definition or the theory behind all this, absolute value of x is exactly that same thing if the thing on the inside is greater than or equal to 0. And it's minus 1 times that thing if the item is less than 0. Another way of looking at it is the absolute value of the difference between two items measures the distance between them. And that should be an A. So the distance between 5 and 7. The minus is part of the formula. So the distance between 5 and 7, if we look on the number line, is 2. And so 5 minus 7 in absolute value of minus 2 is 2. And this says, well, what is the distance between minus 3 and 4? Well, the distance between minus 3 and 4 is 7. And absolute value of 7 minus 7 is 7. So if I'm still thinking about distance, then this is saying find numbers x whose distance from 3 is 2. Okay, well that would mean 3 plus 2 is 5, and 3 going down 2 would give me 1. All right, so let's look at some ALEKS homework questions. Absolute value of a negative number is the negative of it, and so I get a positive. Absolute value of a positive number just comes right on through, no change. All right, in question 3, we're just remembering how do we solve equations. So I want to get the t by itself. So I'm going to take this plus 7, move it to the right. Notice it's a plus 7 here. When I move it to the other side, it's a minus 7. So minus 3 minus 7 is a minus 10, and then divide both sides by 5, and I get that the answer is 2. In question 4, let's see, I see some parentheses. So I know I'm going to distribute this number in, and I get a minus 2x. Minus 2 times 5 is that minus 10 minus 3. And let's see, I can combine these two items, and I get minus 13. I've got the same thing on both sides. And so if I try to get the x's together and the numbers together, I get 0 equals 0. Well, that's certainly a true statement. And what that means when you get that is that all numbers will work. That's minus infinity to infinity, which is the whole number line, which you also see written as R with these two vertical lines. All right, well, let's see. In question 5 here, it says simplify this without absolute value. Okay. So I'm looking at my basic theoretical definition. And so they want me to put inside t minus 6. Okay, I'm just going to put that every place that there was an underlined x before. And so when I look at that, okay, that looks just like the basic formula. And so what do they ask me? What happens if t is less than 6? Well, let's see, less than 6, that looks like this part here, because see, this says t greater than or equal to 6, and this says t less than 6. So if t is less than 6, I've got the bottom branch, which is minus t and a plus 6. And part B says, well, what happens if t is bigger than 6? Well, that's the top branch here, and I just get the same thing back. So all I did was go back to the basic formula here, and everywhere there was an x, I plugged in the thing that they gave us. All right, in question 6 here, they're giving me 3 absolute value problems. First one says it's equal to 2. All right, well, let's see. I'm just guessing. Absolute value of 2, yep, that is 2. And absolute value of minus 2, that's also 2. And so my answers are minus 2 and 2. Sometimes Alex wants you to put these in set brackets. So if it does, just write it inside the set brackets. Absolute value of 0. Well, if I plug in 0 for x, absolute value of 0 is 0. Let's see here. They want me to figure out absolute value of x is minus 4. Well, if I plug in 4, I get 4. If I plug in minus 4, I still get 4. And that's because the absolute value can never give you a negative number. So part C here has no solution, which we write down as the empty set. Question 7. All right, so let's see. Question 7 here says absolute value of x minus 1 is 5, x minus 1 is 0, absolute value of x minus 1 is minus 5. So what do we do? Whenever you have absolute value of something equals a number, and that number is 0 or positive, you just grab everything on the inside, write it down, equal to plus and minus the number. That's because the absolute value will make it positive if it were minus. And if you see absolute value of something equals a negative, that can never happen. Therefore, the solution is the empty set. All right, so here on the first one, let's see. I grab the inside stuff, x minus 1 equals plus or minus 5. I move the 1 so it's 1 plus or minus 5. And then I take care of the plus and I take care of the minus. 1 plus 5 is 6. 1 minus 5 is minus 4. All right, so let's see here on B, it's equal to 0. So I grab the inside. No reason to put plus or minus 0 because that's still just 0. So I'm going to move this minus 1, making it plus, and so I get x is 1. And on part C here, well, this can never happen because I've got a negative number. And so the solution is there is no solution. All right, looking at question 8 here. All right, so let's see. Well, I don't have the absolute value alone, so I'm going to move the number. All right, so I move it over there. I get absolute value of m is 8. All right, so grab the inside, set it equal to plus or minus 8. And so there's our solution with the set brackets. Let's see, what if I had absolute value 2x plus 1 is 10? All right, well, easy enough. Grab all of the stuff on the inside. Make it equal to plus or minus 10. All right, and so let's see, I get 2x because I'm moving that guy. All right, and then I divide both sides, the whole side, by 2. And now I take care of, again, the plus and the minus. 1 plus 10 is 9. 1 minus 10 is minus 11. All right, question 9. Let's see. All right, same deal. It is cleaned up, so I grab the inside stuff. I move the number. Got that. Divide everything by 3. And so if I use the plus and use the minus, I get answers of 8/3 and -2. All right, question 10. Okay, question 10 looks like I probably should clean this thing up first. All right, so I better move the 1, so that would be 3 minus 1 is 2. Still have this guy in the front. I better get rid of it. So I'm going to divide both sides by 2, and so 2 over 2 is 1. And so getting to here, we see it is finally now cleaned up. It is cleaned up, so now I can use what I know about absolute value. All right, so I grab the inside, set it equal to plus or minus the number on the right. I move this plus 7 to the right, divide both sides by 2, and then I take care of the plus here on the top and the minus there on the bottom. And so I get answers of -3 and -4. All right, question 11. All right, so looking here at 11, you might say, oh no, there's a minus on the right. So it has no solution. But I've got this thing in the front I need to get rid of first before I can make any conclusion. So I'm going to divide both sides by this -2. But the good news is -8 divided by -2 is a +4. Okay, that's a good problem. So grab the inside and set it equal to the number on the right with a plus or minus. Move this +3 and then take care of the plus and the minus. And so I get answers of 1 and -7. Question 12, that's puzzling. I have a absolute value on both sides. Now, what that means is I have to do two cases. I've got this plus or minus business here on the right, similar to what we did with the number. Now you might say, well, why would you do that? That seems silly because here there is no plus or minus. Yes, this is the plus version. And this is taking care of something, for example, absolute value of 3 equals absolute value of 3. Notice this is true and the inside parts are equal. And so I can solve each piece and I would get y is 11. On this side, I'm using the minus, and you can think of it this way. Absolute value of 3 equals absolute value of minus 3. Yes, they're equal in absolute value, but the insides, I get 3 equals the negative version, right? Minus y minus 5. And when I solve that version, I get y equals 1/3. Now, eventually, we're going to see that the graph of absolute value is a V-shaped item. So what this problem is doing is if I graph each of my V-shaped items, when you set them equal, it's showing me where the two graphs intersect. And here they're intersecting when x is 1/3 and when x is 11. All right, in question 13 here, they say if n is less than 0, well, what happens to this thing? I don't know, that seems rather confusing. So let me pick a few numbers. I'm going to pick n equal to minus 3. That is less than 0, so let's see what happens. Minus 3 plus the absolute value of minus 3. That's minus 3 plus 3, and I get 0. Okay, that's interesting. Let me pick another negative number, because remember, I'm supposed to pick things less than 0. I'm going to pick another negative number, and let's just see what happens. Minus 10 plus absolute value of minus 10. Okay, well, absolute value of minus 10 is 10, and minus 10 plus 10 is 0. So I picked two different negative numbers, and each time I did it, I got 0. And so let's see, if I use my basic definition, then for n less than 0, it's minus 1 times n, which means I'm always going to get 0. So this is the more formal way of proving it, but we sort of suspected that already because we picked two negative numbers and got 0 both times. All right, well, that concludes section 1.6.